Hello everyone, welcome back to our channel. Today we are going to discuss about current electricity continuation. Our concept is what is the current density. See, current per unit area is called the current density, and we are representing with here it is the J bar. So current density is the vector quantity. Why it is vector quantity? You know that a current is the scalar quantity, area is also scalar, but here we are mentioning here current density is the vector quantity. See, J equals to, it is the ratio of current per unit area, or we are doing the differentiation of current with respect to area, that is also giving the current density. When we are doing the cross multiplication, integration of density into ds, it is giving the current. One more formula we got, how to find out the current. This is the formula for current density. And what is the unit for this? Unit for current density is ampere per meter square. And dimensional formula is IL power minus 2. IL power minus 2. So this is the current density. And one more important topic we are going to discuss now. What is the drift velocity? Till now we know that rate of change of displacement is called the velocity. But in current electricity we have to calculate what is the drift velocity and what is the relation between drift velocity and current. See, drift velocity is represented by Vd. It is the vector quantity. You take one conductor. Conductor is always having the free electrons. These electrons are moving in random direction like this. One electron is going upwards, one electron is coming downwards, one electron is moving towards the left. So resultant velocity of that electrons in the conductor is equals to 0. If there is no external field, if there is no battery connections and we are not applying the potential across the conductor, the drift velocity is 0. Vd is equals to 0. Always we can say iron is a good conductor and it is having the free electrons. Even we are holding the iron conductor, we won't feel any shock. Why? Their drift velocity, resultant velocity of the electrons is equals to 0. But when we feel shock, please don't do this experiment. We are taking that battery connection across the any conductor. Then all electrons are moving from negative to positive. Because of the movement of the electrons, these are having the velocity. That average velocity of the free electrons in the conductor is called the drift velocity. How it is possible? I am showing here. Look. We are taking this conductor. Across this, we are giving the battery connections. Length of the conductor is L. Area of the conductor is A. Area equals to A. Then length equals to L. Across this we are giving, this is the positive and this is the negative. One end we should give positive of the battery. B, you are giving the negative of the battery. So here resultant velocity equals to 0 and there is no meaning for current also in this. Here drift velocity is 0. But in this case, here negative charge you can take it, this is the positive. All electrons are moving from negative to positive. Negative to positive. So in this case, that average velocity of electrons due to an external electric field is called what? Drift velocity. In this case, drift velocity is not equals to 0. And that is the definition for drift velocity. The order of the drift velocity is Vd equals to 10 to the power of 4 meters per second. So this is the general formula for drift velocity. Suppose we are taking n number of electrons are there. First electron velocity is V1, second electron velocity is V2. Like that n number of electrons, nth electron velocity is Vn. How to find out the drift velocity in this case? Vd bar equals to V1 bar plus V2 bar plus and so on. Vn bar divided by n. Sum of the quantities by number of quantities is the formula for average. And one more formula is there for finding this. Here we are applying the current We are applying the potential across the battery is V. And electric field direction is always from positive to negative. How to calculate the potential and intensity in this? Here simply we should write it E equals to V by L. Here V belongs to potential. This is the intensity of electric field. We can calculate in terms of potential and length of the conductor. Like that, how much force is acting on that also? F bar equals to minus E bar E. These are moving opposite to the electric field. That's why we are taking negative sign. When you know the force, we can calculate the acceleration of these electrons. Why? From Newton's second law, A equals to E by mass of the electron m. So like that we can calculate the acceleration. We can find out the intensity of electric field. Finally, how to find out the drift velocity from these two formulas. What is the drift velocity? That is the average velocity. With the help of this, you know that. But in terms of intensity, mass and charge of electron also we can find it. We can go through the first equation of motion. V equals to U plus AT. Here instead of T we are taking tau. This is called the relaxation time. This is called the relaxation time. What is the relaxation? I am not relaxing here. See, between two electrons, sometimes it takes two successive collisions. That is called the relaxation time. And here initial velocity of that one is 0. Final velocity is nothing but drift velocity. Vd equals to 0 instead of A minus E by M. Relaxation time is the tau. So one more formula we got it to find out the drift velocity. So drift velocity is the average velocity of the electrons when we are applying the external electric field. Relation between drift velocity and current. While doing the objective problem, this formula is very important, and how we should find out the relation between drift velocity and current. Suppose you look here, same we are taking one conductor. Length of the conductor is L. Across this we are giving one battery. Battery is providing the potential difference. This is giving to the negative of the battery. See, here L is the length of the conductor. L is the length of the conductor. A is the area of the conductor. A is the area of the conductor. So, per each unit volume, how many number of electrons we are taking? N is the number of electrons. Number of electrons per unit volume. Number of electrons per unit volume. In this case, how to find out the volume? Volume V equals to area into length. But total number of electrons of the conductor. How to calculate this one? We are taking capital N equals to small n into KL. This is the number of electrons across this conductor. This is negative and this is positive because of the applying the potential. All these are moving from negative to positive. And you can take at the same time, this is the direction of intensity of electric field. So we know the number of electrons in the conductor. Then charge of the conductor. Total charge of the conductor. Charge of the conductor. Charge of the conductor is number of electrons into charge of the electron. N into A, L into E. This is the charge of the conductor. We are representing with Q. So we know the charge. For finding the current, you know that flow of charge is called the current. We know the charge. Now we should find out the time. How much time it takes to cross that conductor. Here T equals to distance by velocity. Distance is nothing but length of the conductor. Velocity is nothing but drift velocity, L by Vd. But we want I equals to, take I equals to Q by T formula. So N into A, L into E divided by that time equals to L by Vd. After simplification, I equals to N into A into E into Vd. From this drift velocity Vd equals to I by NEA. This is the relation between drift velocity and current. See, drift velocity, average, with the help of average velocity of all electrons we should find out. And this is from first equation of motion we can find out. And one more is this is the drift velocity I by NEA. Why I am stressing this formula? From this we can write the current density also. In terms of current density also we can express what is current density. Current density is the current per unit area. Vd equals to, we are writing I by A, we are writing current density J by NE. J by NE. From this, J equals to Vd into NE. It should be right product of drift velocity and NE is the charge density. NE is the charge density. You know that velocity is the vector. Vector into scalar also we are getting the vector. So current density is always vector quantity. In previous we discussed current density equals to current per unit area. I mentioned here it is a vector quantity. Why it is vector means it is the product of velocity and charge density. That's why this is the vector quantity.